So a mathematical model can be broadly defined as some formulation or equation in mathematical terms that expresses essential features of the physical system. In terms of how we could write this in a functional form, we could say that the dependent variable phi is, which reflects the behavior of the state of our system, is some function of independent variables, such as our space or time dimensions, parameters that reflect the system properties, for example, density, and also any other external forces that may be acting on our system. The exact mathematical expression of this function can either be simple or complex. Just think of Newton's second law that says the resultant force acting on an object is equal to its mass multiplied by its acceleration. I'm using the overbar notation here to show you that I'm working in vector form. Now this is quite a simple mathematical expression. We could also rewrite this to say that the acceleration, so A over bar, is really just the force divided by the mass. But what's really important is that this mathematical expression describes a process with respect to mathematical terms, and it idealizes something about reality, and this level of approximation is what we as engineers can decide on. And we can decide what is appropriate for our application. So for example, if we're measuring flow in a river, and the flow rates were exceptionally large, you wouldn't need to calculate anything to the third decimal point. And the last point is that the mathematical expression in Newton's second law can be used by us to predict how something is going to behave. So we can apply Newton's second law, for example, to evaluate how everybody is going to fall through space. We might have some object, and this object obviously has some mass attributed to it. And we know from the functional form of Newton's second law that the acceleration is equal to the force divided by the mass of the object. Or the resultant force and acceleration can also be written as the time rate of change of velocity. That is, acceleration is really just the derivative of the velocity with respect to time. And that is equal to the resultant force divided by the mass. We can also then use our scientific reasoning to deduce what forces are acting on the system. So we know that gravity is acting, let's just draw our object here. We have gravity acting down, and the drag, or any type of resistance, is going to act in the opposite direction. This is for the falling parcel example. Now let's explore this in more detail in the next section.